Welcome back to Lesson 69, Saxon's Algebra 1/2 Second Edition. This lesson is on ratio word problems. Now we dealt with ratios and proportions in our last lesson. Now we're going to have them in a word problem and how to set them up and solve them. Alright, so this is one way that you can do this and think of this. A recipe calls for 3 cups of orange juice for every 4 cups of fruit punch. Alright, so in other words, you could say 3 to 4 is the ratio. If a person makes a large batch of this recipe, how many cups of fruit punch will be needed if 12 cups of orange juice are used? Alright, 3 stands for orange juice and 4 for fruit punch. If I use 12 instead of 3, how many fruit punch will I need? Alright, so over here they have orange juice, and they have the chart 3 and 12, and fruit punch 4 and the unknown. The reason they did that is because you need to keep the things that are alike directly across from each other. So 3 and 12 both stand for orange juice, so they're both going to be on the top of the fractions, and 4 and the X are both going to stand for fruit punch, so they're both going to be on the bottom of the fraction. So let's see then. Remember that when we solve ratios and proportions, we cross multiply. When we do that, we get 3x equals 12 times 4, which is 48. Then I divide by 3 on both sides, and I know that x now is equal to 16. So if I use 12 cups of orange juice, I'm going to need 16 cups of fruit punch to keep the same ratio in this recipe. Alright, look at this one. The ratio of tabby cats to Siamese cats was 10 to 3. If there were 300 tabby cats, how many Siamese were there? Alright, so tabby cats will represent as T. There are 10 of those. And Siamese, or S cats, there are 3 of those. Okay, we're going to keep the same order. Then make an equivalent fraction using the actual count. Okay, we know that 10, if there are 10 tabbies to 3 Siamese, and if I now have 300 tabbies, how many Siamese would I have? Well, then I'm going to say, like it's done here, I could say, well, equivalent fraction, then that method would say that 10 times 30 is 300, so 3 times 30 would be 90. Okay, so a ratio is also an equivalent fraction. Alright, one of the examples in your book said the ratio of wrigglers to squirmers was 13 to 2. Alright, wrigglers, squirmers, 13 to 2. When 26 students had the wriggles, how many were squirming? We'll put S. Okay. So 13 and 26 both stand for the same thing, so they're going to both be on the top of the fraction. And 2 and S stands for squirming. They're going to both be on the bottom of the fraction. Alright, so 13 to 2 would equal 26 to what? Well, I can cross multiply. 13S equals 26 times 2, which is 52. If I divide 52 by 13, I'm going to get 4. There are 4 squirmers. I can also look at this and say 26 is exactly twice 13, so twice 2 would be 4. I can do it that way. Alright, your practice problem says the ratio of winners to losers in the valley was 22 to 3. 22 is winners, and 3 is losers. If there were 300 losers gathered in the valley, how many winners were gathered there? Alright, now I've got 3 stands for losers, 3,000 stands for losers, 22 stands for winners, and here that's the unknown. So we're going to say 3 times the unknown would be equal to 3,000 times 22, which is 66,000. And when I divide that by 3, I'm going to get 22,000. I can also look at it this way. 22 over 3, if I've got a 3 here and just added 3 zeros, I can also have a 22 here and add 3 zeros to have an equivalent fraction. Alright, again, make sure you're taking notes, make sure you're writing your practice problem. In your notes, for this lesson, I think you should have at least the last 2 problems that we did. So if you didn't, go back and get that in your notes. And I'll see you next time for lesson 70.